Okay, good morning, everyone. Today we're going to continue our discussion of returns. Last time we discussed sing, single period simple returns. By way of review, the formula is simply the quotient of your price at time t divided by price at time t minus 1, and then minus 1. Okay, this tells us this is what we call the simple returns. Now, if you have a series of returns, you can you can get the multi-period returns, multi-period simple returns by getting the product. Okay, so we learned about the formula, 1 plus the total returns, okay, for the period. So we get the products, 1 plus R1. R1 is the return for period 1. R2 is the return for period 2 until the last period. Okay, and it's equal to this is equivalent to getting the product class product of 1 plus r. So I just so we can just compute for r sub t. R sub t is equal to this product minus 1. Okay, r sub t is a simple return for product t. R total is the total simple return for t products. So if you have, for example, I'll give you a quick question. If the return for period 1 was 10% or 0.10, the return for period 2 was, let's say, 0.6. The return for period 3 was 0.5. The return for period 4, notice I'm talking of returns, okay, is negative 0.2. No, that's big. Wait, sorry. 0.04, and then negative 0.03, and then 0.1. Okay, I'll give you 1 minute, please, to determine what is the return class. What is the total return, total simple return of this this asset given the following 1, 2, 3, 6 periods. So you can compute using R, please. Give you a minute. Kindly write your answer in the chat box, please. Waiting for your answer, class. It's a very simple question. What is the return, total return of this asset having these returns? Total simple return. Anyone, please? What return are you getting? I think the first, I accidentally deleted it. So 10%, 6%, 5%. I think there was a loss of 4%, loss of 3%, and then a return of 1%. Of course, the formula class, as suggested here, if it's a multiple period, it's just 1 plus R1, 1 plus R2. And since you're given the returns, okay, returns per period, okay, then you can compute for the total return. The total return will be equal to, okay, the products, okay, 24%, okay, 0.24, according to Paula. Okay, how about the others, please? How about the others? What's your answer? 24% for Pao. What are the others getting? Just follow the formula, class. Just follow the formula and you will get the multi-period simple returns. The formula is quite straightforward. Okay, how about others, please? Waiting for the others to answer, please. %, kay 1. Not sure. It's okay if you're not sure. Just answer, class, if you're not sure. I hope you used R also in order in getting the answer. How about the others? $25.4. Moises, thank you. Only 3, class, out of 30 plus students. More than 30 does not have an answer. I'll give you a few more seconds, please. I hope I see your answer.
Tas nag-sum returns ako, hindi sir yung prod.
Hindi pa pwede. Hindi pa
Opo.
pwedeng sum returns, class. Kasi simple returns to eh.
Yes,
Okay,
sir.
so very important yun. Thank you, Pao. So it's very important to follow the rule. No? The rule is that when you're computing for the simple returns, you get the product. Okay, you get the product. Now let's see. Let's continue. Okay, so let's just finish the concepts here. All right. So on the other hand, class, on the other hand, if we were working on a log return class, log return, okay, the formula is R sub t is equal to log of the price at time t over time t minus 1. Notice that the standard way to represent your log returns is small r. For simple returns, it's capital R. Okay, that's what you'll see in textbooks in finance. That's I think that's the agreed standard, but these are just anyway representations. So just to follow the standard, R sub t is log returns class, and it's equal to log of P sub t over P sub t minus 1. Then just to quickly have a brief review of log class. What is the log of 100 class? Let me just write log of 100. Log of 100 class. Okay. If you're just reading from the textbooks class, from any journal, log of 100 is equal to, answer, anyone? Answer is 4.6, Adrian. Yeah, but you're correct in this case, but I'm referring to, I'm referring to, if you're reading from a regular textbook, log 100 is equal to 2 class. Okay, 2. Why? Because the assumption here is that when you're getting the log of a number, the assumption is that the base is 10. Okay, the base is 10. It's a silent assumption. So that's why you don't write this. You don't write this 10 because it's assumed that it's 10. Log of 100. So it's the same as log of 100 to the base 10. And the answer is 2 because class, by way of definition, the log of a number is equal to the base raised to its log. Okay, so it's equal to log 10 squared is equal to 100. That's why the answer is 2. The log of 100 is equal to 2 because you are assuming here that the base is 10. Okay, so if I ask you what's the log of let's say, well, let me just make it very simple, 1000, the answer will be equal to 3 because the base here is 10, 10 to the third power. Now in R, okay, you don't use base 10 class. We don't use base 10 because what's more important, what's more powerful is to use the base E. Okay, E is a transcendental number. Okay, it's an irrational number, which means it's non-terminating, non-ending. If you use a powerful computer, and then ask the computer to solve for E, the value of E. Okay, it will generate paper, one paper back to back, font 1, okay, and huge piles of paper reaching the moon and back, and the moon and back. So it's non-ending class. It's such a very powerful number class. It's Euler's number, no? E. And the approximate number of E is, okay, so let's delete this. In R, we use the symbol EXP. So this is E to the first power, and it's equal to 2.718. I don't know if we can increase the decimal run. Let me see if this will work. No. It cannot be E to the E to the is it this way or negative? Let me see. No, it's error. Okay. Anyway, I wanted to increase the decimal places. Okay, it doesn't work, class. So, but it's approximately 2.718182, 1828. Okay, and in R, when we use log, we actually mean log of 100, we're actually using E as the base. That's why log of 100 will not be equal to 2, just like the one that I showed you a while ago. Ito yung sinabi ni Adrian. This is what Adrian shouted a while ago, that log of 100 is 4.6. Why is that so? Because E to the 4.6 is equal to 100. So let me show that E to the this number, Control C, E raised to the 4.60517 gives us 99.999 approximate, only because this was already truncated. This is not actually the exact answer. There are more decimal places there. Okay, so it's 99.9998, approximately 100. Okay, so when you're using log in R, just be aware that you're using the base E. That's the default. How do I generate the log of 100 using base 10? Okay, so you do that by log 100 comma 2. So the comma there signifies the base that you're going to use. Okay, log of 100 to the base 10, this will now give you the answer. It will now give you the answer 2. Okay? All right, is that clear, class? May I have your comment, class, if it's clear? Hey, Adrian, hindi pa rin nila nakita yung answer mo. Okay, when you answer, class, make sure that you share it to everyone so that the others can see your answer. Okay, clear? Okay. All right. Okay, so we can easily get the returns, the log returns of an asset if we know the price at time t and price at time t minus 1. And that's equal to log of, by definition, the log of a quotient is equal to the differences of the logs. Log of p sub t over p sub t minus 1 is equal to log of p sub t minus log of p sub t minus 1. Okay? So if the asset, the price yesterday was 100, okay, and the price now is 100, let's say 115, okay, what will be the simple returns? So the simple returns will simply be 115 divided by 100 minus 1, right? The log returns will be the log of 115 divided by 100, right? And this is just equal to log of 115 minus log of 100. Okay, so take a look at this, class. Okay, there. So this is the simple returns, right? P sub t over p sub t minus 1 minus 1. This is the log returns, and this is also the log returns. So if I run this, okay, so the simple return is 15%. The log return is 13.97%. Just to prove that this is the same as this, the log of p sub t over p sub t minus 1 is log p sub t minus log of p sub t minus 1. So they're the same. Okay, and you'll notice that the simple returns will be greater than your log returns. However, in cases where you have small returns, okay, let's say 100, the price at time t is 100, price at time t minus 1 is 103. Okay, so we have the price now 103, the price at time t is 100. So let's get the simple returns. 103. What I should have done was, okay, I think a better way is A, alt minus. So A, and then I press alt and then minus. For Mac, I think it's command minus 100. Okay, this is better. B, alt minus is 103. Okay, so let's do this, class. Let's create this object A and B. Control Enter. So we now have A and B here. So the return is B over A minus 1. Okay, so that's your price at time t minus t over price at time t minus 1 and then minus 1. And then for the log, it's log of B over A or log of B minus log of A. Okay, log of B minus log of A. Okay, I'm just replicating this, but I'm making it simple. Okay, I'll run this, Control Enter, and then you notice that the simple return is 0.03 and the log return is 0.0295588. Okay. Now, which make us let me have another example. I'll copy this, Control C, Control V. How about if there was a reduction? Let's say it became 90, 98. So price went down. Okay. Control Enter, copy that. And then I'll still copy this one. Control C. Very convenient. Okay. Because we have A and B. Okay, we can still use these formulas. Control Enter. So you can see that the return is negative 0.02. Simple. For log, it's negative 0.0202. It's still lower, class, right? This is lower. Okay. This is lower. This log return is lower compared to the simple return. But we can conclude that, class, for very small returns, what happened here? Okay, here, class. For small returns, okay, such as less than 5%, your log returns will be approximately equal to your log returns will be approximately equal to your simple returns. Take note how I wrote the approximate slash approx. Okay, so let me just copy this in the interest of time. Control C and share it in the chat box. All right, so interpretation for small returns. For example, less than 5%, your log returns will be approximately equal to your simple returns. Okay, once again, may I pause for a while and ask for your feedback? Are you okay so far, class? Any questions? Anything you'd like clarified? Okay, good. Thank you, Jello. Okay, thank you. All right. How about the others? Okay. Okay, thank you so much, everyone. Now, how about for multi-period returns? Now, this is very important. For simple returns, the multi-period returns, the total returns will be the product, okay? The products of the one plus the returns, okay? For log returns, it's different. The formula is different. So it's not 1 plus R sub 1. It's the returns itself. R sub 1 plus R sub 2, okay, etc. plus R sub t. Okay. And that's equal to, you just sum up the returns. Where R sub t is the log return for period t. Okay, R total is the total return for that multi-period. Total log return. Okay, so let's have a very brief exercise, class. Supposing the prices range from 100 and then went down to 99 and then 101 and then 103, and then 101, then 99. Let's see, class. How many periods do we have here? How many periods do we have there, class? Those are prices. How many periods? 6, 6, 6. Okay, 6. All right. Okay, class, please don't make that mistake again. Okay. There are only 1, 2, 3, 4, 5 periods, class. Remember that each period you have to account for the increase or decrease in your asset. So 100 is not a period, class. These are prices. You have 6 prices, but you have 5 periods. Okay? You cannot compute the returns of 100 without the 99. You have to compare it with the present and the previous. Okay? So this is one period. This is another period. This is another period, another period, another period. Okay, so there are 5 periods with 6 6 prices here. Okay, so I'll give you 1 minute, class, to please compare the simple returns and the log returns. Okay, maybe 2 minutes. Good thing we're not going to do this manually, class. So we will be using functions. So we're given the prices. This is what I did just now. 199, 101, 103, 101, 99. So I of course used just variables to denote A, B, C, D, E. So since there are 6, ito no F, no? Okay. All right, good. Thank you, Paula. Yeah, you're correct. Very good. So ito, class, the return. So technically this is not the return, class, no? Kulang pa to ng -1. Okay, but I just use R1 to denote it by okay, let me show you first. Why did I use so R1? It's supposed to be the price at saan na yan? R1 is supposed to be here B over A, right? Dapat may -1 pa to. Okay. Now I didn't put 1 here, class, because later on when we get the product, it will be 1 plus R1, di ba? 1 plus R1. So I didn't subtract 1 so that when I get the total returns, I don't have to add 1. Okay, so parang ano na lang, parang uh, kasi this one, class, and then if you add 1 here, so B over A minus 1, and then when you get the total, you have to add 1. So it's just like getting B over A. So it was just a mental, arithmetic shortcut on my part. So that's why take a look at this, class. The simple return will be R1, R2, R3, R4, R5, right? But my R1 is B over A. I did not subtract 1 so that when I get to the total, I will not have to use 1 plus R1. Okay, just a mathematical trick that I did. All right. And then R1 will be the log. So log of R1. So I can also use this. P sub t over P sub t minus 1. Okay, anyway, that's pretty straightforward. And I'm getting here. Okay, log return total negative 0.0100504, which is what Paula shared. Okay, and then simple return is negative 0.01. Okay, and you can see that the log return is lower than that of your simple return. Okay, so I think that's enough example. Okay, now you can also do this. So if you have your, let's see, if I have my, this one class, okay, but this is only for 2 periods class. So here you have 2 periods. Okay, this amount and this. So this is your return, log return for period 1, log return for period 2. So the corresponding, okay, where's that? So the total log return is simply adding this class, right? So if you add this, it becomes 0.441441. And if you can convert this log return into simple total return. And this is the formula class. R sub t is equal to e to the r sub t minus 1. Let me share this with you. This example. Okay. And we can convert class the log return here. The log return is the log return is 0.1441, and then to get the simple return, it's e raised to the log return minus 1. Okay, e to the log return minus 1, 0.155. Let's see if it will work here, class. This one, will it work here? Okay, so if I if I get the exponentiation of e to the this one, control C, this one, right? And then minus 1. Okay, you can see that it's correct, plus negative 0.01. You get this. Okay, you can convert your exponential return, okay, to the you convert it to a simple return. Vice versa, class, vice versa. So given the r sub t, how can you compute for r sub t, the exponential? Okay, wait. Oh, time na pala. Okay. Just this last one, class. We were able to show, class, that, okay, here the formula, the simple return is equal to, this is the log returns, right? E to the log returns minus 1. Okay. And again, class, can you please compute for this one? E to the 0.441, 1441 minus 1. What do you get, class? Kindly chat, please, as we end the session today. Use exp, class, to get the exponentiation. Exp to the 0.1441 minus 1. What are you getting? Hello, class. Okay, around 1, yeah, this is not exact. No, around 1.155, around this one, class. So uh, dropping off the last decimal places, 0.155. Now, if it was the reverse class, okay, if you're given this 0.155, and you notice that the simple returns is greater than your log returns. So how do we now get the log returns class given the simple returns? So from this formula, and then I'll end here, class. Okay, from this formula, so we first transpose 1 here, right? So this becomes r sub t plus 1 is equal to e to the rt, r sub t, okay? All right, then how do we compute for the r sub t? We have to get the log of this class. So log of 1 plus r sub t, okay, which is this one, class. Log of this is equal to log of this one. Now, the log of your exponent, class, the log of exponentiation is equal to the exponent, class, okay, because these are inverse functions. Log of exp, so this cancels out. This becomes r sub t. Okay? All right, so if you have 0.155, so get the log of 1 plus 0.155 class. What do you get? Last question, class. Thank you. Log of 1 plus 0.155. If we're trying to get the log returns, log of 1 plus, this is 0.155. What's the answer, class, please? Okay, the answer is 0.144, okay, which is this one, class. This one. So we were able to convert, class, yung simple returns sa log returns. All right, so let me end there. Okay, thank you so much, class. Let me stop recording.